Hey guys, welcome to another video, and this is a tutorial on how to solve the Siamese cube. Check it out. So this is a Siamese cube, as you can see in front of you, and it is actually a kind of a 3x3 mod, I would say. So yeah, let's just get started. So the first step is you need to know how to orient the cube. So since now I prefer holding it like this with the, just a minute, the frame is too small. So I usually prefer holding it like this, where one cube is on the top right and one in the bottom left. So now you can see that if you hold it like this, now orange is on top. So, and now you hold it like this, it's red on top. So I'll get to that part later. So first, to just hold it like this, it's more comfortable if you use your right hand more. So before any further ado, let's just get started, and I'm gonna just jumble this cube in 3, 2, 1. Okay, so the cube is jumbled, or rather the cubes are jumbled. So now the first step is to orient the centers. Now I'm gonna, which are these three. Now this is the center because it's kind of embedded here, and yeah, it's kind of embedded there and it doesn't move out of its position. So we're gonna call that as the center. So first we're gonna do the white and yellow, but we just need to do the white or yellow, because then if we do white, then the yellow will automatically get solved. So you can see 2 of the whites are done. So now I'm gonna search for the last white, which is right here. So I have to just turn this middle layer like this, and as you can see, we have all the 3 white centers done. Sorry if the brightness is a bit low. So the next step is to get the other 5 centers in place. Now as I told you, if you hold it like this, orange is on top. If I hold it like this, red is on top. Now I don't remember that. So what we're gonna do is, holding it like this, we're gonna see how many orange pieces are here, orange edge pieces are on this cube, and how many red edge pieces are there on this cube. So let's count red first. So red, there are 1, 2, 3, and 4. Now orange, there are 1, 2, and 3. Now if orange were to be on top, it would be missing 1 edge. Red has 4 edges, so in this case the red center is going to be on top and not the orange. Similarly, if you were holding the cube like this, it would be either blue or green. So now red is on top already here, so we'll just get red on top over here as well. So you can see that the red is here and it needs to go here. Now we can't do this because the M move is restricted. So what we do is we bring its position down while knocking at the white to, not disturb it. We put this, the red center has to go here, so we just put it in, and then we bring the white center back up so that the red is in place and the white is still preserved. Now the next step is to insert these 2 edges. Because we're doing that first because this is kind of immovable. So since these 2 pieces are kind of immovable, so you can't do the second layer algorithms for this, like the L one. Although you could do it from here, but then you have no F moves on either side. So to insert this, we'll just have to do this. This is the white and blue piece, as you can see. Let's search for that. It's stuck here. So if it's like this, then we just turn it out like this twice, like it's stuck there. So we do a U2, like both these layers or just the middle layer, and then you turn this thing so that the white matches with the white, and just bring it back so that this is in place now. The next one is the blue and yellow, which is right here. So we just put it up in the top layer, and now you can see the yellow is not matching with the yellow. So what we need to do for this, just do a U and L move, so that now yellow is matching with yellow. So you put this out so that this is now in a free position. And then you just do an L2, L2, yep, and that matches it up, and now you can just put it back. And now the first step is done, which is inserting these two. The next step is to form the cross, the bottom cross. So let's see, we have the orange and white which has to go here, so that's right here. So we put it up on the top layer, and now you can see white is not matching with the white. So what you do in this case, you put I'm gonna do an algorithm for this, but it's really not necessary. So you just put this above where it has to go, and you do UI M U M I. So now it's there. Let's just move it out of the way, bring its position up, put it in, and bring it back. The same one for this, green and orange. It's right here, so we just need to turn it down. Now, what if this piece was to be inverted? Let me just show you. What if a green wasn't matching with the green? Then you'd have to flip this piece. That's why we haven't done this one before. Like, we haven't done this cross piece before this, because we need one free space to flip this edge. So we put it above this, and then we do an M, and just, you bring this up, move it out of the way, and bring this back down. And now the green is matching with the green, so you can just put it down. The last cross piece is the yellow and orange, so that's right here. It's the same case, so I'm gonna make a different case for you. Now the yellow is matching with the yellow, so what you do is just you do an M, U2, and just bring this back. And now you have this, the cross done. And now as you can see, this kind of, the corner and the edge over here is done, so I'll just have to demonstrate here. So for the corners now, F2L is pretty difficult on this, so I tried it once, but there are a lot of variations. So this one is the white, orange and green, which is stuck here, so we just bring it up, and then we just flip it. So now the white is on, the orange is on the right, so we can just insert it. Now for now here also we do the same thing, but it's already done, so that's alright. Now the next is the second layer piece. The second layer piece is this right here. Sorry about the fumble. This is white and green. Now we need the green matching with the green in this case, and not the white matching with the white. So we need to flip this edge, but we already have these two places filled. So we are actually gonna knock out one of these. In this case, I'm gonna knock out this. So I'm gonna do the same thing to flip the edge, and now the green is matching with the green. Now you do this algorithm, keeping this on the right. U2 R U R I, U2 R U2 R I, U2 R UI R I. And as you can see, this piece is inserted. This piece is still knocked out. Do not worry, that you can just simply insert it like how I showed you before. So now we have the first two layers done. For this side, you just do the mirror of that algorithm, which I will display on the screen. I'll just read it out. U2 Li UI L, U2 Li, U2 L, U2 Li UI UL. So now these two, and while doing this, you don't need the blue matching with the blue, you need the green matching with the green in this case. So moving on to the last layer. So for the last layer, again, it's the same as a 3x3. You can have the backwards L, the line, or the cross, or the dot. So in this case we have the line. Now we can't do an F move in this, so this is where I refer to another video. So the modification of the F here is this. These two layers up, U, and this down. That whole thing is the F. Now we had the line, so that was F. I'll just do it. So now we have the line, so F R U R I U I, and then we just do the same thing to get it back. We have the cross, so we just do it RU, RU, RU2. Alright? We have it. Now we can't do the thing anti-soon from here, so we just turn it around and then we do it from here. Now we have the top face and ooh, the cube is solved. I'll be back with a PLL. Okay, so this is one PLL case where you have two edges and swaps. So this is simply the Z perm. So we just do it U and U2 and U2 and U2 and U3. Okay guys, so I tried to get other PLL cases but I couldn't. But I'm just gonna give you a few tips to solve this last layer, PLL kind of thing without parity. So the first thing you want to remember is that you do not want a single adjacent swap. It's like these two faces are solved and these two need to be swapped, otherwise you'll end up with a parity. Also, you do not want two opposite faces solved, or otherwise again you'll end up with a parity. So I'll go on ahead and solve this cube, and I should be able to get another PLL case, and mostly I will. So I will be back once I complete the the orange face on this and show you the PLL case I get on it. Hey guys, so I'm done with the yellow face, and I did manage to end up with another PLL case where you have one side solved and the other three need to be rotated anti-clockwise or clockwise, doesn't matter, the algorithm remains the same. So what you have the solved side, you keep it on the left, and then you do this algorithm: R2, U2, R2, U2, R2, U2. Now you have two adjacent faces solved. But I told you that you should avoid having a case like this. But if you already have a parity where these two pieces are switched, then it's okay to have this case. So now if you have this, you keep these two unsolved ones on the front and right, and then you do this. You'll know these algorithms if you watch my 3x3x2 tutorial. So the algorithm goes like this: R2, U, R2, U, R2, U2, R2, U2, R2, U, R2, UI, R2. So there you go guys, that is the Siamese cube tutorial. Those are the only two PLL cases as far as I know. Again, I told you to avoid cases if without the parity. If you have two adjacent faces solved or two opposite faces solved, you'll end up with a parity. So try to avoid that as much as you can, and mostly you won't be able to get direct cases like that. So anyways, thanks for watching this video. Hope you liked it, and please share and subscribe, and thanks for watching.